Have you ever opened a math book and felt your brain just shut down when you see a bunch of weird symbols? You are definitely in the right place. Today, we're going to crack the code on set notation and Venn diagrams so you can walk into your exam feeling totally confident.
Yeah, symbols like these. They can look pretty intimidating, almost like you're trying to read an alien language, right? Well, what if I told you that by the end of this quick explainer, these symbols will be your friends? Let's do it.
Okay, so first things first. Before we can start decoding the symbols, we've got to understand the world they live in, and that is the world of sets.
So what on earth is a set? Honestly, it's just a collection of things. Think of it like a bag. You can put whatever you want in it. Numbers, letters, your favorite songs, whatever. The only real rule is you have to wrap it in these curly brackets. So here, we've just got a bag containing all the factors of 6. Simple as that.
All right, now that we know what a set is, it's time to learn the language. Think of this next part like getting a crash course, a cheat sheet for all the main symbols. We'll go one by one, and by the end, you'll be fluent.
First up is this fancy E symbol. This is the universal set. All this means is it's the universe for that one specific problem. It's the big box that contains every single thing we could possibly care about for that question. So, if we're talking about factors of 24, our universe only contains those factors. Nothing else even exists for that problem.
Okay, next one, N of A. When you see this, don't overthink it. It's just asking a really simple question. How many things are in set A? That's it. It's just a head count. If set A has the numbers 1, 4, and 9 inside it, then N of A is simply 3.
Now for the fun ones. This symbol, which kind of looks like an N or an upside-down U, is called the intersection. The key word you absolutely have to remember here is AND. It's asking what's in set A and in set B. It's the stuff they share, the overlap.
And this is its partner, the union. It looks like a U. Now, if intersection means and, union means or. It's everything that's in set A or in set B or in both. You just throw everything from both sets into one big collection. Just remember not to list the same item twice.
Last one for now is this little dash here, the complement, and the keyword for this one is not. So a complement, or A prime, just means everything in the whole universe that is not in set A. It's all the stuff on the outside.
Okay, we've learned the lingo. But here's the best part. We can actually draw this stuff. It's time to bring in the most powerful tool for this topic, the Venn diagram, which turns all these symbols into a really simple picture.
And boom, here it is. This is where it all clicks. See how the union is both circles shaded in? That's our OR. The intersection is just that little bit in the middle where they overlap. That's our AND. And the complement of A is everything shaded outside of circle A, our NOT. Venn diagrams just make it all make sense visually.
So, we have the symbols, we have the pictures. Now let's put it into practice. We're going to walk through a typical exam-style problem step by step and see how this all works together.
All right, check this out. Here's our Venn diagram for the problem. We've got two sets, A and B. The numbers inside the circles are the elements, and those numbers floating around outside, they're still in our universe, just not in A or B. Let's use this picture to answer a few questions.
First up, let's start with something straightforward. What is NA? Remember what that N is asking? How many total items are inside that entire circle for set A?
If you got 5, you nailed it. The key is to count every single number inside the A circle, and that includes the part that overlaps with B. So, we've got 2, 6, 12, 14, and 28. That's 5 elements in total.
Okay, now let's zoom in a bit. Look at the numbers 14 and 28. They're sitting in a pretty special spot. How would you describe that little area using the symbols we just learned?
Exactly. Because they're in that shared overlapping space, they are in set A and set B. So we write that as A intersection B. It's that AND relationship we talked about.
All right, let's switch gears to the other symbol. Can you list out all the elements that would be in the set A union B? Remember what the union is? It's everybody invited to the party from both circles.
For the union, we just scoop up every single number we see inside either circle A or circle B. So we get 2, 6, 7, 12, 14, 21, 28, and 35. We've united them all into one big superset.
Okay, time for a bit of a challenge. This is the kind of curveball they might throw at you in an exam. Someone claims that the set of things not in A
and not in B is an empty set. Is that person right? Take a close look at the diagram.
This one's tricky, but that statement is definitely incorrect. Let's break it down. Not in A is everything outside the A circle. Not in B is everything outside the B circle. We want the intersection, the stuff that's in both of those groups. We'll look at the numbers 1, 5, and 8. They are outside of A, and they are outside of B. So the set isn't empty at all, it's 1, 5, 8.
And just like that, you've gone from symbols to solutions. So to wrap up, here's a little something for you to think about. If you have a set T with the letters T, E, A, M, and a set M with just M and E, can we say that M is a subset of T? In other words, is everything in M also inside T? Think about it. Thanks for watching, and good luck.